Bright Duty. Every student matters.
Now, this was a survey conducted by an organization for the cause of illness and death among women between the ages of 15 to 44 in years worldwide. Found the following figures in percentage. Causes: reproductive health conditions caused 31.8% of the female fatality. Neuropsychiatric conditions caused 25.4% of female fatality. Injuries 12.4, cardiovascular conditions 4.3, respiratory conditions 4.1. Other causes caused 22% of the female fatality. Represent this information given above graphically. So I consider the correct representation would be through a bar graph. So we will take these conditions, these causes on the horizontal axis and these percentages on the vertical axis. So let us take let us take a gap of 1 centimeter each for each of these conditions, right? So let us start with this gap here for the first condition, that is reproductive health conditions, right? Serial number 1. And the second one is neuropsychiatric conditions. So I am writing it by writing neuro only, right? But you write the complete statement here, neuropsychiatric conditions. The third one is injuries. Fourth one is cardiovascular conditions. So I am writing cardio here or cardiovascular. The next one is respiratory conditions. So let me write respiratory here. And the next one is other causes. Other causes, right? The percentages I require up to 31.8. So let me represent this with the gaps of 5 each. Okay, so let me mark it 5 here, then 10, 15, 20, 25, 30, 35, 40. Okay, corresponding to reproductive health conditions, what should be the height? The percentage that we want to represent here is 31.8. So the height should correspond to 31.8, which is approximately here. So this should be the height of the bar corresponding to reproductive health conditions. So let me draw this bar here. Right, so this is the bar which represents reproductive health conditions, and obviously this point here on the vertical axis is corresponding to 31.8, and this vertical axis represents female fatality rate in percentages. So you write it here. Okay, next one is neuropsychiatric conditions, 25.4. So the point will be somewhere here, and this will be the corresponding height for this graph of neuropsychiatric conditions. Right? For injuries, I'll take 12.4 as its height, which is somewhere here, and this should be the height. Now this bar represents female fatality rate in percentages because of injuries, and because of cardiovascular 4.3%. So it will be somewhere here. The graph that I am making using the solid lines is the bar graph, and these dotted lines I am using just to see the heights, corresponding heights. and respiratory conditions 4.1. So this will be the respiratory conditions bar, and for other causes 22 should be the height. Let it be somewhere here, and this should be the approximately height of this bar. When you use a scale and pencil and proper graph paper, you will get the correct bar graph. Now this is the bar graph for this given data. Okay, now looking at this bar graph, you can interpret some of the data points. How? Represent this graphically. We have already represented it. Which condition is the major cause of women's ill health and death worldwide? So the cause for maximum illness and death of women will be where the height of bar is maximum. So which bar is of the maximum height? This one. So reproductive health conditions is the answer for this question. Reproductive health conditions, right? Try to find out with the help of your teacher any two factors which play a major role in the second subpart, that is this part above, being the major cause. Okay, so you need to discuss it with your teacher and find out. So some of the reasons that may be there can be lack of nutrition for the ladies in those conditions, and the other reason can be lack of knowledge, and this reason can also be lack of education, right? Okay, education doesn't necessarily mean the knowledge of these reproductive health conditions, but yes, when the education is there, then you have better resources, you have better doctors who can take care of these conditions there, right? So these may be some of the reasons. Okay, the following data on the number of girls to the nearest 10 per 1000 boys in different sections of Indian society is given below. So this is female to male sex ratio which is given here. Number of girls per 1000 boys. In scheduled caste categories, there are 940 girls per 1000 boys. So in a society, if you count the number of boys and number of girls, this data gives the number of girls corresponding to 1000 boys. So if there were 1000 boys in that particular category, there were 940 girls corresponding to those 1000 guys, right? So in scheduled caste category, there were 940 girls per 1000 boys. In ST, 970, non-SC ST 920, and the data is given like this. So we need to represent this data using the bar graph. Again, we will make a vertical axis and horizontal axis. On horizontal axis, we will take uniform gaps to represent each of the category. For example, there is first category SC. So I'll use this bar for this SC category. Now ST. Next category is non-SC ST. Non-SC ST. Next one is backward districts. So this will represent backward districts. The next one is non-backward districts. This one will represent non-backward districts. And then rural and urban. So this one will represent rural and this bar will represent urban. How do I check the heights? Widths I have taken as uniform widths. Now I need to check their heights. So heights will be corresponding to these numbers, these frequencies, right? Corresponding to SC, I need 940 as the number on vertical axis. So these numbers, if you notice, start from 910, go up to 970. Okay, so let us start here from, let us say, let us give this gap of 900. So this much gap I am representing 0 to 900. So I'll use the same gap 900 to 1800 here. Okay, so between 900 and 1800 I'll have these data points 900 to 970. Now on vertical axis, let me change the scale. On vertical axis, let us take the scale starting from 100. This will be 200, 300, 400, 500, 600, 700, 800, and then 900 and 1000. Okay, so if you see these, all of these points will lie between 900 and 1000. Okay, so I require on the vertical axis between 900 to 1000. So let me take this as 900 and this as 910, 920, 930, 940, 950, 960, 970, 980, 990 and 1000. You can take a suitable scale, you just need to mention it here. So this point here represents 900, okay, for this particular question. So in SC category, we have got 940 girls per 1000 boys. So the height of this bar corresponding to SC category will be up to this point, which represents 940 on the vertical bar. Okay, now for ST, I require 970 on the vertical axis. Okay, so this will be the height of the bar which represents ST category. This is 920 non-SC/ST. So where is 920? We have got this much height for non-SC/ST category. For backward districts, 950 is the ratio. So 950, the height will be somewhere here. This should be the height of this bar. And for the next one, non-backward districts, 920. These are non-backward districts. So this should be the height here. For rural section, 930, corresponding to this height. This will be the bar for rural section. And for urban section, it is 910. Okay, now you need to observe these bars. This is the bar graph. What can you observe? That the height of this bar, which corresponds to urban section, is the lowest. Okay, and the height of this bar, which corresponds to ST category, is the highest. Right, so based on these heights of these bars, you can make certain observations. For example, in the classroom, discuss what conclusions can you arrive at using this graph. We can arrive at the conclusion that the ratio of number of girls to per 1000 boys, that is known as sex ratio, which is highest in case of ST category. So sex ratio is the highest for ST category, right? Another observation that you can make is that the sex ratio is the lowest in urban section, right? You can make other comments also like this, that the sex ratio in rural segment or rural section is better than the sex ratio of urban section. Okay, so these are the observations you can make using this bar graph, and that is the use of these graphs, so that you can interpret the given data in a better way. So in a glance you can see which one gives the better ratio. Okay, now here in the next question, there are the data, this is the data for seats won by different political parties in the polling outcome of a state assembly election. Political party A won 75 seats, political party B won 55 seats. So we need to draw a bar graph to represent these polling results. So obviously we will have the political party's name on the horizontal axis. For example, let me take this much width for party A, this much for B, which is same as this one, right? I will maintain the uniform width everywhere. For party C, D, E and F. So I have taken the widths of these bars, rectangular bars, as the uniform widths of 1 centimeter each. Okay, so now I need to decide their heights, which will be given on this vertical axis. So heights start from 10 and then go up to 75. So let me mark it by 10, 20, 30, 40, 50, 60, 70, 80. Right? You can choose a corresponding scale depending on the data. So this vertical axis will give me the seats won, and this horizontal axis will show me the political party. So political party A won 75 seats, so the height of this bar will be corresponding to 75 here, and this will be like this. Okay, political party B won 55 seats, so 55 will be here, and this should be the height of this bar. Corresponding to political party C, the number of seats won is 37. So 37 will be somewhere here between 30 and 40 and near to 40. So this will be the height of bar corresponding to political party C. Political party D won 29 seats, so which will be here. Political party E won 10 seats. And political party F won 37 seats. So 37 will be somewhere here. Right. So this is the bar graph which represents this given data. Now, just by looking at this bar graph, what can you say? Which political party won the maximum number of seats? So obviously you will look at the highest bar, which is this one. So which political party won the maximum number of seats is party A. You could have seen it from this table also, because 75 is the maximum number of seats won here. But if I do not give you this table, I just give you this bar graph. Just by looking at the highest bar, right, you could have said that party A won the maximum number of seats. And what is that number? You will look at the vertical axis corresponding to this height, and you would have found that party A won 75 seats, which is the maximum number of seats. Okay. The length of 40 leaves of a plant are measured to correct to 1 millimeter, and the data obtained is represented in the following table. Lengths in millimeters are given 118 to 126, 127 to 135 and so on. Number of leaves 3, 5, 9 and so on. We need to draw a histogram to represent this given data. Now you need to take care that while drawing histogram, we require continuous class intervals, right? And these are discontinuous class intervals, so 126 and 127. So there is a gap of 1. And how do we make it continuous? How do we make an inclusive class interval into an exclusive class interval, or a discontinuous class interval into a continuous class interval? We see the gap 126 and 127, there is a gap of 1. We divide that gap by 2, so it is 0.5. We subtract it from the lower limit and add it in the upper limit. So the first class will become, if I can write it here itself, length in millimeter. So the first class will become 117.5 to 126.5. I have just subtracted 0.5 from the lower limit and added 0.5 in the upper limit. Okay, similarly, I'll subtract 0.5 from 127 and it will give me 126.5, and I'll add 0.5 in 135. So it will give me 135.5. Now you would have understood by now that the classes will be something like this: 135.5 to 144.5. Next we'll start from 144.5 and go up to 153.5. Next one will be 153.5 to 162.5. Next one will be 162.5 to 171.5, and the next one will be 171.5 to 180.5. So these are the classes now in the continuous class interval, right? So let me make a histogram for this data. I will take these classes on the horizontal axis. Okay, so the class starts from 117.5. So I'll draw a kink here just to show the continuity, and let me say this is 117.5, this is 126.5, this is 135.5, this is 144.5, this is 153.5, and the next one that I had was 162.5, 171.5, and the last one 180.5. Okay, now see, corresponding to this class, number of leaves is 3, and here if you see, the maximum number you have is 12 and the lowest one is 2. So let me take the suitable class interval as 1, 2, 3, 12. Okay, so the height of this corresponding to this class will be 3. What I mean to say is that the height of this rectangular bar will be 3, and corresponding to the next class the height will be 5. So the next bar will go up to this height of 5, right? So there is no gap between these two bars. This is one solid figure. 135.5 to 144.5 has got height of 9. So the height will go up to here, and width is same for all these classes. So you don't have to worry about adjusting the frequencies corresponding to the widths, as we did in a question previously. For this one, the height will be 12. So it will go up to maximum height. Okay. Next one goes up to 5. Next one 4. now 2. Okay, so this is the histogram that represents this given data. Is there any other suitable graphical representation for the same data? Yes, we can always make a frequency polygon. We can make this frequency polygon using this histogram itself, or we can make it directly using the class marks. Okay, we can find the class marks for these classes and corresponding frequencies are these. You can directly find the coordinates of those points and join those points to become a frequency polygon. Otherwise, you just find the midpoints, you take the midpoint of this, and this, and then you make a imaginary class equal to this width here, okay, and take its midpoint, and before it also you need a class of same width and you take its midpoint. Now you join these points to make a frequency polygon, which will have the same area as the histogram that we have drawn. And I have explained it to you previously that why would it have the same area. Let me once again tell it to you, because this area, now in the frequency polygon this area is not covered, right? But we have got this extra area here which is equal to this one, because these two triangles, this one and this one, these are congruent triangles, right? When you draw this frequency polygon and histogram using the scale and pencil on a graph paper, you will see that these triangles, this one and this one, these are congruent triangles, right? Hence the area while drawing the frequency polygon, which is cutting off from the histogram, is getting adjusted by these extra areas, right? And is there any other question? Is it correct to conclude that maximum number of leaves are 153 mm long? So where is 153? 153 is somewhere between 144.5 and 153.5. Now this bar has got the maximum height. So you may tend to answer this question in yes, that there are maximum number of leaves having 153 mm length, right? But no, because this is a class which is for the leaves having lengths between 144.5 to 153.5, and this is a class, right? This doesn't represent a particular number 153. So we cannot say that maximum number of leaves are 153 mm, because there may be leaves, maximum number of leaves may be between 144.5 and, let us say, when you look at this class, in this class itself there may be maximum number of leaves which are 145 mm long. Okay, so, and if you want to find an absolute number, which are the maximum number of leaves with maximum number of you want to find the length of maximum number of leaves, it may be there in this class also. It is not necessary that it lies in this class, okay, because this is an interval in which all these lengths are there. Okay, so answer to this question is no. Okay. The following table gives the lifetimes of 400 neon lamps. Lifetime is in hours, 300 to 414 lamps, 400 to 556. So we need to represent this data by using histogram. And how many lamps have a lifetime of more than 700 hours? So we need to draw a histogram. So we need horizontal axis and vertical axis. On horizontal axis, I'll start from 300. So let me draw this kink here. Let it be 300, and then 400, 500, 600, 800, 900 and 1000. After 1000 also let me take a class 1100, and before 300 let me take 200 also, as we have discussed earlier also, that we require them to complete the frequency polygon. But here I just need to draw a histogram, so I may not need these, but I have taken these just to show you that while making frequency polygon we would require these. So 300 to 400, the height that is to be taken is 14, and in this data the maximum height that we would require is 86 and the minimum is 14. So let me take the scale, suitable scale, as 10, 20, 30, 40, 50, 60, 70, 80, 90 and 100. Okay, so 14 is the number for 300 to 400, so let it be here. This is 14. So for this class 300 to 400, this will be the height, right? Now between 400 to 500 we have 56 lamps, so 56 is somewhere here. This will be the height for this bar or this rectangle here, right? 500 to 600, 60. Okay, 600 to 700 we have 86. 700 to 800 we have 74. 800 to 900, 62. And then 900 to 1000, it is 48. This is the histogram for the corresponding data. Okay, now if I ask you to draw a frequency polygon, you will just take the midpoints of these horizontal segments between 700 to 800. We have got 74. Okay, so this is not something that we require, right? And for this next one, 1000 to 1100, we will have frequency as 0, and 200 to 300 also we will have frequency 0. Now we will join these to form a frequency polygon. We have to join these by straight lines, so you will use a scale to do this. Okay, so this is the corresponding frequency polygon. Now let us look at the question. How many lamps have a lifetime of more than 700 hours? So more than 700 hours means these lamps. So you have to add these data. More than 700, you have to add these three numbers. So you will add 74, 62 and 48. 62 plus 48 is 110. 110 plus 74 is 184. So this is the answer for this question. How many lamps of lifetime more than 700 hours? It is 184. The following table gives the distribution of students of two sections according to the marks obtained by them. Section A and section B. Represent the marks of students of both the sections on the same graph by two frequency polygons. From the two polygons, compare the performance of two sections. So let me draw two polygons on the same graph. Now see, I will directly draw the polygons without drawing the histogram. For that, I will require class marks. So let me write the class marks here itself. class marks. What are the class marks? The sum of lower limit and upper limit divided by 2. So for this class it will be 5, for this one it will be 15, 25, 35, 45. Similarly, these class marks will also be the same, 5, 15, 25, 35 and 45. So let me draw a vertical axis and a horizontal axis. On the horizontal axis I need 5, 15, 25, so the suitable scale, let me start with 0 here, then 5, 10, 15, 20, 25, 30, 35, 40, 45 and 50, then 55 and 60. Okay, and on the vertical axis I require the maximum number as 19. Okay, and the lowest one as 1. So let us take this as 2, 4, 6, 8, 10, 12, 14, 16, 18 and 20. Okay, so this is the scale I am taking on vertical axis. Vertical axis will represent frequency and the horizontal axis will represent class marks. Okay, so corresponding to section A, okay, class mark 5 will have frequency 3. So it will be this point here. This is 3, so this point will represent 5, 3. So 5 on horizontal axis and 3 on vertical axis. For this one, 15, frequency is 9. So for 15, frequency is somewhere here. So the point will be this one. Okay. This point represents 15, 9. And then 25, 17. 25 is this one and 17 will be here. So the point will be, corresponding point will be this one, 25, 17. Let me erase these dotted lines so that I just have these points that I have to join to complete the frequency polygon. And next class mark is 35, which will have frequency of 12. So this will be the point. Okay, and corresponding to this class mark 45, we will have 9 as its frequency. So the point will be somewhere here. Okay, let me erase these lines. Now before this class of 0 to 10, I'll have an imaginary class minus 10 to 0. Okay, so for minus 10 to 0, I'll have to go here. Okay, and the corresponding class mark will be the midpoint of minus 10 and 0, that is minus 5. So this will be the class mark for this imaginary class. And I have to go beyond these classes also, 40 to 50. So I'll have to take 50 to 60 as my next class, and the corresponding class mark will be 55. So this class mark will have 0 as its frequency. So which point is 55, 0? This point is 55, 0. Okay, so I will join these points to make the frequency polygon, which shows me the performance of section A. So this is the frequency polygon corresponding to section A's performance. Okay, I need to draw the frequency polygon for section B on the same graph. Okay, and for these classes also, the previous class will be this one, minus 10 to 0, and the next class will be 50 to 0. So these points will be same for section B also, right? Let us look at the rest of points. So corresponding to class mark 5, we have got frequency 5 this time. So this will be somewhere here. This will be the point. Okay. Corresponding to class mark 15, we have got frequency 19, which will be here. So corresponding to 15, we will have the point here. 15, 19. Next point that we require is corresponding to the coordinates 25, 15, right? Class mark is 25 and the corresponding frequency is 15. So 25, 15. 15 will be somewhere here. So this will be the point. Corresponding to next class mark 35, we have got frequency 10. So it will be somewhere here. And corresponding to next class mark 45, we have got frequency 1. So this will be here. Okay, and corresponding to 55, we again have frequency 0, and corresponding to -5, we have got frequency 0. So we will join these points to give the performance graph of section B. Right, so this color is for section B. Right, now you can see these two graphs on the same graph paper. Okay, on these polygons on the same graph. So you can compare the performances. How? Because between 0 to 10 marks, we have got more number of students who are in section B. Between 10 to 20 marks, there are more number of students in section B, right? So up to this much, right, between 20 to 25, there are more number of students who are there in section B. But when we think about scoring more number of marks, that is 22.5 to, let us say, 55, there are more number of students in section A who are scoring higher marks, right? Because this graph, this red one, is lower than this black one after this point, right? So more than these marks, the performance of students of section A is better, and when we consider the lower marks between let us say 0 to this one, 0 to 20, or you can say section B has got more number of students in this area, right? So what can you say about their performances? More number of marks are scored by section A students. Okay, now let us look at the next question here, which says the runs scored by two teams A and B on the first 60 balls in a cricket match are given below. Number of balls 1 to 6, team A scored 2 and team B scores 5 runs. Okay, similarly for 7 to 12th ball, team A scored 1 run and team B scored 6 runs. So this is the data for these two teams A and B, and now we need to represent the data of both the teams on the same graph by frequency polygons. So we are going to do it on the same graph like the previous question and then compare the scores. So it is always good to represent two set of data on the same graph for the comparison purpose. Now if you look at these classes are discontinuous, right? 6 and then 7, there is a gap of 1. So what do we do to make it continuous? We divide the gap by half and then subtract it from the lower limit and add it to the upper limit. But in this particular question, this is about number of balls. So if I add 0.5 and 6, it will become 6.5 balls, which doesn't make sense in this question. So the appropriate way to make it continuous will be if I take this class as 1 to 7, right, and this class as 7 to 13. Now what happens is this has become exclusive interval, right? So 7 anyways is not considered in this class, it will be considered in this class. So this class interval can be made continuous by writing it 1 to 7, 7 to 13, and then 13 to 19, 19 to 25, 25 to 31, 31 to 37, 37 to 43, 43 to 49, 49 to 55, and then 55 to 60. Okay, so if you think that the gap or class width is 6 here, so it is 6 here, 6 in this also, 6 in this also, but in the last one it is 5, so you can take 61. Okay, for the sake of the consistency or to make these class widths same. Obviously 61 is not included here because we are considering first 60 balls only, right? So this won't make a difference, right? Now our graph will be okay. For 1 to 7, the frequency or the runs scored for team A is 2. How do we represent it? If we had to make a histogram, we could have directly made the histogram and uh, then draw the frequency polygon from that histogram. One of the ways is this. Second way is to draw the frequency polygon directly, which we did in the previous question also. For that, I would require class mark. And what is class mark? It is the upper limit plus lower limit divided by 2. In this case, lower limit is 1, upper limit is 7. Their sum divided by 2 will give me 4. So class mark for this particular class is 4. Right? What is the class mark for next class? 13 plus 7, 20 by 2, that is 10. For this one, it will be 19 plus 13, that is 32. 32 divided by 2 is 16. So you see there is a gap of 4. 4 plus 6 is 10. 10 plus 6 is 16. So it will be 22. I have added 6 in this, right? So it will be 28, then 34, 40, 46, and then you add 6 here, 52, and then you add 6, that is 58. Okay, so these are the class marks corresponding to these classes. Right? Now I'll draw the frequency polygon taking these class marks on the horizontal axis and these runs on the vertical axis. So let me draw a vertical axis and a horizontal axis. On horizontal axis, I'll have class marks. So the class marks are like this: 4, and then we have 10 and 16, 22. So what is the scale that you will take here? You can choose a convenient scale. I am choosing gaps of 4. So 4, 8, 12, 16, 20, 24, 28, 32, 36, and I have to go up to 58. So 40, 44, 48, 52, 56, 58, and the next one will be 62. Right? So I have taken gaps of 4 as my scale on horizontal axis. Now on vertical axis, I will require these runs, right? And the maximum I require is 10, minimum is 1. So let me take a suitable scale, 1 to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10. Right? Corresponding to the class mark 4, I have got for team A runs 2. So 4, 2. This will be the point. Okay. I am representing team A with team A scores with black color. So corresponding to this class mark 4, I have got 2 runs for team A. Class mark 10 and then runs is 1. So class mark 10 will be here and runs scored is 1. So this will be the point. Okay. For class mark 16, the runs scored by team A is 8. 16 and then 8 on vertical axis. So I'll have this point 16 comma 8. Okay, 22 and 9. So 22, I'll have 9 somewhere here. So I recommend that you use a scale and proper graph paper so that you can find these points accurately. Right, and the next point will be 28 4, 28 and then 4 will be here, and the next one is 34 5, 34 is here and 5 is this. So 34 comma 5 is this point. Next is 40, then 6, 40 and then 6 will be somewhere here. Okay, so corresponding to this 6 you will decide this point. Right, I hope you are comfortable with coordinate geometry and you can find the coordinates. So what we are doing here is when I'm saying 40 and then 6, I am finding the coordinates 40 comma 6, right, 40 comma 6 I am trying to find. So it is not 38 comma 6, it is 40 comma 6. So this point 40 comma 6 will be here. This is the coordinate, or this is the point corresponding to the coordinates 40 comma 6. Right, so the next point we will find is 46 comma 10. So 46 is here and 10 we will have here. So the point will be this, right, and the next one is 52 comma 6. So 52 is this one and 6 we will have here. This is 52 comma 6, and then we have 58 comma 2 or 58 2. So 58 and then we go up to height of 2 units. And now if I join these points, these are straight lines. Okay, so you need to use a scale. So you join these points to complete your frequency polygon. But is the frequency polygon completed? No. So what do we require now? We require the previous class or the previous class mark before this 4, right? So 1 to 7 we have taken a class of class width 6, right? So the previous class or a class before this, which may be an imaginary class because the negative numbers will also be included here, will be -6 -5 comma -5 to 1. So it will be, let us say this is -5 and this is 1. So what is the class width here? It is again 6, right? So what will be the class mark for this class? -5 comma 1. You add these, right, -5, and then what is the gap between -5 and 1? It is 6 units, right? So I require the point between these two, so it will be -2, right? So I'll join this -2 with this point to complete my frequency polygon, and I'll require a class after this also, that is 55 to 61. Then I require 61 to 67, and the midpoint here will be 61 plus 67 divided by 2, which will be 128 by 2, that is 64. So corresponding to this point 64, what will be the frequency? 0, right? So this is 66 and I require the class mark 64, and the frequency is 0, so it will be on the horizontal axis itself. So you join this. Now this is the complete frequency polygon which represents scores of team A. Okay, now to draw frequency polygon for team B, I don't have to look at the horizontal axis, I just have to look at the vertical axis now. Why? Let me explain it to you by taking a different color. So I have selected red color for team B. This is for team B. Now you don't have to look at horizontal axis. Why do I say that? Because corresponding to this class mark, the frequency is still 0, right? Because no one has scored -2 scores. Okay, or there is nothing like -2 as number of balls. So this is an imaginary class that we have taken just to complete our frequency polygon. Now corresponding to this class mark 4, so 4 I don't have to see, I just have to see this now. Team B has scored 5 marks. So above this point I'll have this point for team B. Okay, corresponding to this class mark 4, I'll have 5 here. And corresponding to this class mark here, what is the next number? 6. So I'll go up to this height, 6. Okay, corresponding to the next class mark, which is 16, I'll go up to 2 units. So this point will be below this point and it will be somewhere here. I hope you have understood this logic. Corresponding to class mark 22, we will have 10 as our height. So 22 is already marked for this, right? So now I just have to see the height. It will be 10 in this case. So the point will be here above the point, the black point, right? Which was for team A. Next height is 5. So it will be this. And the next height is 6. So it will be above this point. That is this. Next one is 3. So it will be below this point, which corresponds to this 40. Or you can verify it from here itself. 40, and corresponding to 40, the frequency or the number on the vertical axis was 6 for team A, and here it is 3. So obviously this point will be below this point, which is true in this case, right? Now for the next, it will be 4. So it will be below this point and here, right? So these red dots and black dots are either above each other or below each other, right? So which makes sense because the class marks are same for both the teams. Now the heights are different, right? Because they have scored different runs pertaining to different number of balls. Okay, and the next one is 8. So it will be above this point here, corresponding to this height. And the next one is 10. So for this class mark, it will be here. And obviously for 64, the point will still be here. The frequency is 0 for the next class mark, which we have taken just to complete the frequency polygon. Now I'll join these points to complete the frequency polygon for performance of team B. It will be here. Right, you need to join these by using straight lines. So you will use a scale to do that. I am drawing just a rough diagram for your understanding. So these are the graphs for team A and team B. You can see that their performances vary, right? So if you look at just 0 to, let us say, up to here, up to 8 balls, if you see, the team B performed better, right, in the initial set of balls. And if you look at this segment, 12 to up to, let us say, 18, depending on this graph, right, you can check it here. The graph of team B is below this black graph of team A. So the performance during these balls was better for team A, right? So this is how you can do the comparisons depending on the number of balls. Okay, so if you want to compare the performance between 49 to 54th ball, so you just go here. So this is roughly 49 and this is 54. So between these two, which graph is lower? Again, you cannot comment, because between 48 to roughly 50, the performance of team A was better, and between 50th to 54th ball, team B was performing better, right? So you can make your conclusions depending on these data points, right? After, if you see, after 50th ball, roughly the team B performed better because its graph is above the graph of team A. Okay, so this is the use of drawing the graphs simultaneously on a single graph paper. A random survey for the number of children of various age groups playing in a park was found as follows. Age group 1 to 2 years, 2 to 3, 3 to 5, and so on. Number of children 5, 3, 6. Draw a histogram. Now, while drawing histograms, you just need to see two things. One, that it is a continuous class interval. In this case, it is a continuous class interval. There is no gap because the upper limit of this class is the lower limit of next class. So there is no gap. And second thing you need to take care is of class width. Class width, the minimum class width is 1. 1 to 2, the class width or class size is 1. For this class size is 1. 3 to 5, the class size is double. So you need to make the frequency half here, right? Because while drawing histograms, we are concerned about the area of those rectangles that we make, right? If you draw it like this, 3 to 5, frequency 6, then the interpretation will go wrong. Okay, where the class size is getting doubled, you have to halve the frequency here. For 5 to 7, the class size, again the double of the minimum class size, which we have taken as 1. So it is 2 here, so I will divide it by 2 now. Here 7 to 10, the class size gets tripled. It is 3 times the minimum class size of 1. So what I will do is, I will divide this by 3. 10 to 15, the class size became 5 times the minimum class size, so I will divide this by 5. And 15 to 17, the class size is 2, so what I will do is, I will divide it by 2. Right, so these will be my new frequencies for the histogram. Now let us draw the histogram. Or what we can do here is, we can take this space. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. We won't require more than this, right? So 1 to 2, it is 5. What do I mean is, this is 1, this is 2. Between these, the height should be 5. So these are the heights, right? So let me take these as this 1, 2, 3, 4, 5. So if you see, you won't require more than 5. 1 to 2, it is 5. So the rectangle or rectangular bar will be like this between 1 to 2. Okay, between 2 to 3, it is 3. So continuing this graph as one solid graph without any gaps horizontally. So the height between 2 to 3 is 3. What is these? What are these heights? These are number of children. Number of children. So you need to mention this, that on vertical axis you are showing number of children, and on horizontal axis you are showing age in years, right? So now between 3 to 5 it is 6 by 2, that is 3. So 3 to 5 is this much. Now the width is getting doubled. You understand why I have made it half? So it will be 3, between 3 to 5, right? And between 5 to 7 it is 6. Okay. Between 7 to 10 it will be 9 by 3, that is 3. So 7 to 10 up to here. Okay. And the next class is 10 to 15 and the height will be 2. 10 to 15 up to here. Like this. Okay. 15 to 17 it will be 2 again. 15 to 17 it will be 2. Okay. So this is the histogram for this given data. It is important that you take care of the class widths. So the method to draw this graph correctly is to see the minimum class width first, which in this case was 1, right? So the frequencies corresponding to the minimum class width are to be taken as it is. So for example, in this case minimum class width is 1, so the frequency I took was 5, right? Now if the class width changes, here the class width became double, 2 times, so I have to divide the frequency by 2. Here the class width becomes 3 times, so I have to divide the frequency by 3, right? If I do not divide it, the area corresponding to this frequency will become more, right? And it will be a wrong representation of data. We have already discussed about it in our previous questions. Okay, so this is the histogram for the data. Okay, now from this histogram, what can you interpret? So this was about number of children playing in a park, right? So if I ask you which age group children, what are the maximum number of children, in which age group out of the children playing in the park, what are the maximum number of children of a particular age group? So you will look at the highest bar here, right? So in the age group of 5 to 7, maximum number of children were playing in the park, right? In this age group, 5 to 7. 100 surnames were randomly picked up from a local telephone directory, and a frequency distribution of the number of letters in the English alphabet of the surnames was found as follows. So number of letters were 1 to 4 in surnames 6. 6 surnames were such which had number of letters from 1 to 4. Similarly 4 to 6, 6 to 8, 8 to 12 and then 12 to 20. So if you look at the continuity, classes are continuous, but if you look at class width, here the class width is 3, here the class width, in this class the class width is 2, in this class it is 2, in this class it is 4, and in this class it is 8, right? So the class width is varying, but the minimum class width is 2. So for 2 we will keep the frequencies as same. Okay, now here the class width is 3, it has increased, right? So for the increased class width of 3 we have to adjust the frequency. How do we do that? Class width has increased, so I have to divide it by something. So if I divide it by 3 and multiply it by 2, now the class width will be adjusted, so it will be equal to 4. Okay, so this is the height. Now in this class the class width is double of the minimum class width, so what I'll do is I'll divide it by 2 simply, and here it is 4 times the minimum class width, so I'll divide it by 4 and it will become 1. So this is 8, this will remain the same as 44, this will remain 30, and this has become 4 now. Okay, what I mean is, corresponding to class width of 2, there was a certain frequency which we had taken as it is. Okay, now the class width is 3, but the frequency given here is 6. When I say frequency, I mean the data or the number that I represent on the vertical axis. So corresponding to this, we have given 6. Now if this was 2, what would it be? This 6, right? So if I make it 2, if I make it 1, it will become 6 by 3, that is 2. Now if I make it 2, 2 into 2, it will become 4. That is why this 4 is here. Okay, now I need to draw a histogram. For the histogram, I'll have these classes here, 1 to 4, and then 4 to 6. So you can do it like this: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20, right? So between 1 to 4, there were 4 surnames. So 1 to 4, there were 4 surnames. So what I require on the vertical axis, I need to have these numbers, out of which 44 is the maximum number, right? So what I'll do is, I'll take the numbers like this. Let me take it as 5, 10, 15, 20, 25, 30, 35, 40, and then 45. Okay, so corresponding to this class 1 to 4, here the height will be 4. So I'll go up to this point here. This will be the rectangle. And 4 to 6. So I'll go up to here, and the height will be 30. So 4 to 6, I'll go up to 30. Okay. 6 to 8, it will be 44. So 6 to 8 will be 44. Right. 8 to 12, it will be 8. 8 to 12, it will be 8, somewhere here. Okay. 12 to 20, it will be 1. So 1, let us say, is here, and 12 to 20 will have this rectangle. Now this is the histogram for this given data. Write the class interval in which the maximum number of surnames lie. So maximum number of surnames, that is this height. So this rectangle corresponds to the maximum number of surnames, and the class is 6 to 8. So this is the required class, 6 to 8. And let me represent this number of letters is being represented on horizontal axis, and number of surnames on the vertical axis.